Hey Claude, I just published my first MCP video. Can you update my to-do and tell me what's next?
Let me check your to-do list first. Congrats on publishing. Let me mark that as done. Your first MCP video is officially checked off. What's next is disappear for 24 hours. Sounds like a well-earned break after the launch.
Interesting. What you're seeing here is not the AI making things up. These tasks are coming from my actual to-do list, and this was achieved using the Model Context Protocol. If you want to build this yourself, follow along in the rest of the video. Hey there and welcome to the MCP Playbook, a series where we break down how large language models go from reasoning to real-world execution using Model Context Protocol. In this video, we'll build an MCP system that maintains and manages our to-do list. Let's get started. Before we move on to coding, let's look at the components involved in a typical model conversation. In this tutorial, I'm using Claude as the LLM. Claude has a free tier with some message limit, but that's usually sufficient to build and run this simple MCP. Anyway, the model runs inside a model inference server. As a user, you never really interact with the model directly. You go through a client. A client is something like Claude.ai in your browser or the Claude Desktop app installed on your machine. I'll be using Claude Desktop here because it's more flexible for setting up MCPs on the free tier. In a simple scenario, the flow is straightforward. When the user asks a knowledge question, the client forwards that request to the model server. The LLM reasons over the prompt, generates a response, and the answer flows back to the client and onto the screen. Now let's look at a different scenario. Imagine the user has a local file called todos.csv with a list of tasks and their statuses. If the user asks, "What are my pending to-dos?" the client can still forward the prompt to the model, but the LLM could hallucinate and it can't produce a grounded, correct answer. Why? First, the model runs on a remote server and has no access to your file system. Second, the model is purely generative. It can reason about what should happen, but it can't execute code or read files by itself. So how do we bridge this gap? Let's say you've written Python functions to perform CRUD operations on that CSV file, like add, read, update, and delete to-dos. These functions are wrapped in an MCP server, which exposes them as MCP tools. The key detail here is that MCP server connects to the client, not the model server. Now, when the user asks about the pending to-dos, the client sends the prompt to the model along with a list of available MCP tools. The model reasons over the request and replies with instructions like call this tool with these inputs. The client then invokes the MCP server. The tool executes real code on the local system, returns the result to the client, and those results are forwarded back to the LLM. Finally, the LLM uses the real execution results to generate a clean, human-friendly response for the user. This is the core idea behind Model Context Protocol. The LLM decides what should happen, the MCP server executes what actually happens, and the client just connects the two components. Now that the architecture is clear, let's build it step by step. Let's import the Python modules. I'm using pandas to perform data operations on the CSV file, using pathlib to handle file paths, and most importantly, I'm using fastMCP to set up the MCP server. Let's define the current directory. Then we define the data directory where we store our to-do list, and then we define the CSV file path. Let's define a function called setup to create the data directory and the CSV file, creating the data directory, and then creating the CSV file if it does not already exist. I'm defining 3 columns, ID, name, and status, and saving the data frame. Now let's define the functions to perform CRUD operations on the CSV file. We'll have add to-do to add a new item, get to-dos to fetch the items, update to-do to update the status of an item, and then delete to-do to remove an element from the list. Let's fill in each function. Add to-do takes the name of the to-do as an argument, reading the CSV file, creating a new row with a new ID, name, and status, The initial status will be not started, updating the data frame with the new row, and then saving the data frame. Here we just return the new row as the output. For get to-dos, we take status as an optional argument. If a status is provided, we return only the items with that status. Otherwise, we return all the to-dos. Loading the data frame, filtering by status if specified, and then returning the rows. For update to do, we take ID and optionally name and status, loading the data frame, getting the index of the record that matches the given ID, updating the name and status if provided, saving the updated data frame, and then returning the updated record. Finally, delete to do needs just the ID. We load the CSV and find the matching index. If the record is not found, we just return a failure message indicating that the task is not found. If the index is valid, remove the record and save the updated data frame. Finally, we return a success message. Alright, now that the functions are ready, we'll expose them as MCP tools. Creating a new fast MCP instance. Adding a decorator called mcp.tool to all the 4 functions. By adding this decorator, we are transforming the regular Python functions into MCP tools. To host these tools, let's write the code to get the server ready. Before starting the MCP server, calling the setup function to ensure that the CSV exists, adding a startup message, and then calling mcp.run. That's it. This is all the code needed to set up an MCP server for the to-do list. Now that we plan to interact with Claude, we need to associate this MCP server with it. So first I go to my Claude Desktop app and go to Settings, then select the Developer tab. Here we see that there are no servers added, so let's click on Edit Config. We should be directed to a config file. In my system, it is Claude Desktop config.json. In this file, we can add the MCP servers, and this is the format. First, let's add the name of the MCP server, then the command. As the MCP server is set up in Python, we need to add the full path of the Python executable on your machine. And then within the arguments, we add the full path of the to-do MCP Python file we just created. Alright, with that, the to-do list MCP server is built and integrated with Claude. Let's test this by interacting with the AI. I start by asking, list down my to-dos. The model is requesting permission to call the get to-dos MCP tool. I'll select allow. Since the file was just created, there are no items yet. I'll add one to clean my room so that it stops looking like a crime scene. The model is requesting to call add to do, allowing that now. You can see the task is added. Now we will add another task to subscribe to 100 folds. Well, this is the cue for you all to subscribe to this channel. Please go ahead and subscribe. Once that is done, let the AI know that you have subscribed. Now it's requesting to call the update to do tool to mark the task as complete. Now let's say I didn't clean my room for days and don't want to keep seeing it stuck in my list. I can choose to remove this to do. This time it wants to call the delete to do tool to remove it from the list, and done. That's it. We have tested all the 4 tools that we have created. The MCP server is live, connected to Claude, and it is also handling tool calls in real time. With that, we wrap up the first video in the MCP Playbook series. Let me know in the comments how it worked out for you all. You can find the code in the GitHub repository link below. I'll see you all with a new and slightly more complex MCP use case. Until next time, happy coding.
Want me to mark that disappearing act in progress? Done. Now go enjoy that break.